The theory of parallel universes is now well established in science, physics, but what we don't talk about as often is the nature of parallel universes and whether they are all existing as real, concrete, tangible universes, or whether they are all or some of them existing as probability waveforms. Waveforms is a wave, just the wave of probability. So where the wave is higher, your probability is closer to 1, and where the wave is lower, then the probability is closer to 0 of finding the particle there, or of it having specific properties. Like a photon or an electron, these particles that don't actually exist as anything more than probabilities of being found where you look until we observe them. And then when we observe them, when we detect them or when we measure them, then when we bring them into existence, they're manifested as real in our reality. What if these parallel universes also exist in these probability waveforms where they're just in a superposition state of all possible properties, and it's only when we observe them, detect them, measure them, that they're brought into existence as real universes, as existent, manifest universes. So then, what CERN is doing is trying to detect parallel universes. That's one of the main objectives of the CERN project, and you can read about it on their website. So if these parallel universes are like the particles in our reality, in our universe, not made concrete, manifest, real, until they're detected, measured, observed by human consciousness, then what are the consequences of detecting these parallel universes? If by detecting them we bring them into existence, then how does that impact not just those universes, but our own? Because if by detecting a parallel universe, we bring it into existence out of a superposition state of probability, if prior to our observing it or detecting it, measuring it, the parallel universe is just this superposition state of possibility. It's a probability of a universe, but it's not an actual universe. And it's only when we detect it that it becomes an actual universe. Then, by detecting a parallel universe, we're bringing it into existence, making it real. We're also granting it the power to detect our own universe. Do you see? So, if that universe exists as a superposition state universe, it's just a probability waveform. It's not concrete. It's not manifested reality. It's just a probability waveform of the universe. And as soon as we observe it through detection, measurement of CERN, then it becomes manifested. It becomes real. It becomes an actual universe existing there. And then that grants it the power then to turn around and observe our own universe. And so what if our universe is or was a probability waveform universe, not manifested yet, just this superposition state of all possible histories? And then by being detected, then that collapses into one real universe with one past history. And so all of a sudden, all these potential histories, these potential pasts, are collapsed into one actual past. And then that's the one that we find ourselves in at the moment of detection, at the moment that our universe is measured or observed. So the consequences of CERN trying to detect parallel universes could be that we're affecting our own universe, because we don't know up until that point if our universe is a real, manifest, concrete, or if it's just a superposition state universe, if it's just a probability waveform of a universe. When particles are doing their thing up until the point that we observe them, they're just probability waveforms. Waveforms is a wave, just the wave of probabilities. So where the wave is higher, your probability is closer to 1, and where the wave is lower, then the probability is closer to 0 of finding the particle there, or of it having specific properties. Light can be polarized in different directions. So light can be going like this as it waves through the universe, or it can go like this as it waves through the universe, coming towards your eye. But until you detect it, it's actually traveling in every possible polarization state. Oh, like this, but also like this, and also just at diagonal. And then when it hits your eye, then all those possibilities of polarizations collapse. And then one polarization state is what you detect. And then also the past history of that photon collapses down to match the one polarization state that you detect, that you measure. And so all those other possibilities now are, in a way, erased. So what if our universe was in a superposition state where different realities, different possibilities of a reality, different probabilities were existing? And then when we were detected, then all of that just had to collapse into one detected state. And so then all the other possibilities, probabilities, were erased, and we're left with this one manifest universe, this real universe, as it is. So these are implications that I don't know that CERN scientists were really thinking about when they set out to run these experiments. I think they were just thinking, we have all this funding and we've created this big machine and it's super cool and we're gonna smash particles together and measure all the smashings to see what we can see. I don't think they really applied any philosophical examination of the consequences, and I think that that's really irresponsible. And one of the problems in our society that leads to this kind of nonsense is that everyone is so forced into this narrow stream. So in order to become a physicist that works at CERN, you have to spend a number of years only studying this very specific branch of science. You don't necessarily have time, or you're not rewarded for, and you're not incentivized to spend any time thinking about philosophy or psychology or trying to figure out different philosophical implications of your work. That's for somebody else. That's for someone with a philosophy PhD. You are working on a PhD in quantum physics, and so you only are going to be studying quantum physics. But then this is how just disasters and reality starts to crumble and shift. Maybe. Is this testable somehow? Can we figure out somehow whether our universe has changed in any way from a superposition state to a collapsed, actualized state? I suspect that we might see differences. It seems to me that the probability of anything being really close to 1 where it happens and really close to 0 where it doesn't happen would maybe be more likely in a universe that's manifested, that's been brought into existence. Whereas in a universe that is still existing in a probability waveform state, in a superposition state, in an undetected state, then I would expect the p-values to be more spread out. If our universe was still undetected, unmeasured, that no other universes, peoples in other universes had observed our universe yet, then I would expect that the probability values would be more widespread. So our bell curve describing different things would be fatter and just this wider bell curve, because there would be more probabilities. Whereas once the universe is detected and then everything collapses into set properties, then I would expect the p-values, the probability values, I would expect the probabilities to be more narrow. So things either do occur or they don't occur. Things either are or are not. So I think there should be somewhere in there, this should be something that we can test, that we can measure, maybe. The only problem is that when we make the measurement, the observation, when we detect the particle or the universe, then when it collapses into something real, the alternate histories are erased, like we saw with the light wave, the photons, and the electrons, and they've done it with other particles. All the possible paths are taken, but when it's measured, it collapses, and then the only past history, the only path taken, is the one that we find that when we've detected it, and everything else is just erased. So I don't know that we could do a comparison between p-values before and p-values after the moment of observation. But maybe human consciousness seems to work differently, because our consciousness is what, in many ways, determines the collapsing of these probabilities into actualities. So there is something that seems to be different, special, about our consciousness and how it interacts with reality around us. So I wonder if our consciousness is somehow able to remember, to keep track of the alternate pasts that were erased when we were detected. And so there's no record of it in the universe, in the same way that when a light particle is measured, is observed, is detected, then all of the different polarization states that it was in, they're all erased, and just the one polarization state is detected. And all the other ones are not detected. Their probability is just down to 0, and then the probability of it having this particular polarization just shoots up to 1. So this is how it's polarized. What if our human consciousness keeps a record of the other paths that were taken prior to that collapse that happens when detection occurs? This suggests that maybe our universe has been detected or is being detected. And here's an interesting thing. When humans observe a particle and then it collapses into a particle from just this weird thing of probabilities, it doesn't then forever, for all eternity, stay as a particle. We focus our attention on it, and then it becomes brought into existence from this soup of probability. And then we focus our attention away and we do something else, so we move on with our day. And then that particle will eventually slip back into a superposition state. It will slip back into a soup of probabilities until it gets detected again by another human being or by the same human being. So this does suggest that our universe could be detected multiple times, and each time it would collapse into one manifest reality, and then eventually it would go back to this soup of probabilities, and then if it gets detected again, then you'd see another collapse. And why do we have different memories of different past histories? Because not all possible paths have the same probability. So going back to the light polarization, so maybe the up-down polarization has a probability of 70%, And then the side-to-side probability has a probability of 10%. And then the angular, just diagonal one, has a probability of 5%. And then the other, this percentage is just spread across other possibilities. So then maybe when it's detected and then it becomes this collapses into an up-down polarization, then maybe, now I'm going to transfer this to the analogy of human beings and the universe and blah, blah, blah. Then you'd see 70% of people who would remember the up-down past, and you would have 10% who would remember the side-to-side, and 5% who would remember the diagonal, and then a smattering of people who remember something different. That would actually account very well for what we see with the Mandela Effect, because there are some things that we have. Some people remembering the Berenstein bears, and that's the universe that we find ourselves in right now. That's the manifest reality, Berenstein. A large chunk of people remember Berenstein bears. But there is also a small group of people who remember the Berenstein bears. So, in fact, this analogy works super well. Am I onto something? I think maybe I'm onto something. I don't know. If you would like to talk to me about this and you have some background in these kinds of things, then get in touch with me and let's talk, because I'm interested in this. A lot of these ideas seem very crazy or out there, but in fact they're not. They're very much in line with what science is publishing. And the fact that a lot of people are going to see this and just think this is crazy, it kind of goes to show that we're very narrow in what we will consider for what's happening around us, because maybe we're more comfortable living in a universe that we understand thoroughly. Reality. Subscribe to our channel, and we make a new video every Monday. My list is a lot less noticeable on Tuesdays. Subscribe to my channel. I share a new video every Tuesday. Monday, I voted for Tuesdays. I will make more videos about trucks and guns. Subscribe to my channel. I share a new video every Mondays. Tuesdays. Really?